Technologic, 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 technologic.
Hi, my name is Olivia Kennedy and I'm going to be talking about the new latest prototype developed by Microsoft called ThinSight. ThinSight consists of an optosensor. Basically, an optosensor contains a light emitter and a light detector. It needs to be an LCD screen in order to work, so basically it can only be used with laptops as of yet. The infrared light emits directly through the screen, and any reflective object such as a finger placed in front of the screen will reflect infrared light back onto the detector. So it basically, that's how it tracks the finger motion. I'll draw out a simple diagram to show you. Okay, so here would be your LCD screen. Then embedded behind the LCD screen you'd have this device called an optosensor. So you'd have arrays of optosensors here. So each array would have a light detector and a light emitter. So it emits light through the LCD screen, and any object, say there's your finger, it'll reflect the light back and it'll detect the change in infrared. Now, however, what it can also do is, if you place an object there, it'll also reflect back infrared light, so it can detect objects. The best thing about ThinSight is that it can detect the location and the shape of an object placed in front of it. So you could have both multi-touch while having an object there that's interacting with the system. Also, what you can do is, if you have an infrared pen, a light LED pen, you can interact with it from a distance. Because this technology is new, there are still a few errors with it. For example, when an object is placed between optosensors, it tends to disappear. So in order to combat this problem, they have to make the infrared detectors more sensitive. There needs to be a higher frame rate for more responsive user interface, and also the power consumption for the ThinSight is 350 milliwatts, just for the optosensor alone. If you want to see a working prototype of ThinSight, you can call into the Microsoft Research Centre in Cambridge.
I'm Eamon and I'm going to be talking to you about Diamond Touch technology. This technology is a method of creating a touch-sensitive surface which allows for multiple and simultaneous users to interact with. Diamond Touch works by using antennae which are embedded in the surface and creating a circuit which passes through the user into a receiver and back into the table. Circuit runs from the transmitter through the antenna, through the user, to a receiver which is allocated to each user, and then back again to the transmitter. Each antenna transmits a different electrical signal. When the user touches an antenna, an electrical signal is sent from the transmitter through the antenna, through the user, into a receiver, which in this case is their chair, into the computer, which sends it to a projector which relays the information back onto the table.
Hi. I'm going to talk about the frustrated total internal reflection system. It's a way of implementing a touchpad relatively cheaply. How you do it is you set up a perspex sheet, which is this right here. Along the sides of the sheet you lace it with LEDs that emit infrared light. So the infrared light, due to total internal reflection, it just gets reflected around inside the perspex sheet but doesn't escape. So the light's trapped. So once finger pressure is applied to the surface of it, it upsets the balance of the total internal reflection, which allows light then to escape through the bottom of the pad, which is reflected off a mirror and picked up by an infrared camera. How the FTIR then, how they do it to make it instead of a touchpad, make it into a touch screen, all they do is add a digital projector which will project an image off the mirror onto the back of the perspex sheet, and on the underside they put a really thin sheet of paper with a gap of air between it, so it's to act as a diffuser. That would be like a projection surface that the projector, or that the image will get projected onto, but it actually won't upset the balance of the FTR, of the total internal reflection, so no false signals will be sent. So, and again, when you put your finger against the sensor, the light will go through the diffuser layer and it'll still be picked up by the camera. Okay, what we got right here is the MT Mini. It's like the most simple touchpad you can make yourself. Basically, it's a box with a webcam inside. Nice view of that, right there. So what we got here is just a Perspex sheet with a bit of tracing paper to act as a diffuser, and see when you touch it, your finger, I don't know if you can see that, but your shadow comes through the inside, and that's all that is tracking. We've got our boy to demonstrate how this MT Mini works, so if we go to my lovely assistant Eamon, he's going to explain. He's not going to explain, I'm going to explain. So what he's doing is just moving his fingers along the touchpad. Inside the box is a webcam. And right here on the first screen is what the webcam is actually seeing. That's just a picture. So the second screen turns into a grayscale image, as in black and white. Third screen flips the image, so whites become blacks, blacks become whites. Just makes it easier to detect. This one, you can set the transparency of the background. So if you had a high color background behind you or something like that, it wouldn't affect it. Or if you're on bright light, you could turn it up or down. Settings of it. Next one is just a high pass filter, just simple. It'll you can make the blobs bigger or smaller by adding noise or taking away. This is a scaler. It just can make the points more intense in brightness or turn it down. And finally, this is actually what the computer sees in the end. This is the points that it's going to use for tracking. So move around your fingers there. So basically, it'll track points. So that's how the MT Mini works. Okay, so right here we've got a demo called Smoke. It's just powered out. It just comes with the MT Mini software, and basically all it's doing is picking up your finger points wherever you put it, and it's assigning a random color to each finger that kind of follows you as you go, like.